So when the gas is well insulated, no heat can flow into or out of the gas. When the gas is compressed, work is done on the gas. Thus, the gas gains energy. That energy manifests as an increase in the average kinetic energy of the gas particles. So, the temperature of the gas increases since kinetic energy is proportional to the temperature. So, the answer to the first part is work. So, when gas is insulated, Q is 0. So no heat inflow or outflow of the gas. Now when gas is compressed, work is done on the gas, hence work is negative. Now this energy results in a gain in energy of the gas. So if we use equation 15.1, the first law of thermodynamics, we know that del U is equal to Q minus W, and Q here is negative and work is Q is 0 and work is negative. So negative times negative is positive. So this will be equal to modulus of the gas or just the modulus of the work or just the positive value or absolute value of the work. So this means that del U is positive, or as I said before, the gas gains energy, and energy is 3 over 2 nr delta T. So, in simple terms, energy is proportional to the change in internal energy is proportional to change in temperature. So, if del U is positive, this means that delta T is positive as well because the rest of the part is positive. And this means that temperature increases. So that's the first part. Now, in the second part, when gas expands, the opposite effect occurs. So, if gas expands, work is done by the gas. By the gas, which means that work is positive now. Again, applying equation 15.1, the first law of thermodynamics. Also, the gas is insulated before, so Q is 0 as well. So no heat flow into or out of the gas. Now del U is equal to Q minus W, where del U is the change in internal energy. So we substitute these two and we see that this is equal to negative times W, and here work is positive, so we can write this as minus uh, modulus of W. Since work is positive, so W is in fact equal to absolute value of W. So I have just written that in this form so as to denote that del U is negative here because it's like negative times a positive value. So del U is negative, and this means that gas loses energy, or since del U is negative, we can say that del T is negative because as I said over here, del U is proportional to del T, and this means that temperature decreases. And you can also say that because there is a loss in energy of the gas, so the average kinetic energy of the gas particles also decrease because the gas has uh, lost some work. Work is done by the gas, and through in that process, there is some energy loss, an internal energy loss by the gas. So the average kinetic energy of the gas particles decreases, and hence, since kinetic energy is proportional to temperature as well, temperature decreases. And the same reasoning can also apply to the first part. Thank you.